We've probably heard the phrase that kidneys filter blood, and yet that's true. The urinary system does a lot more than just filtering blood. Filtering blood sounds like all they do is get rid of waste. But kidneys, and therefore your entire urinary system, is a very important system that regulates the homeostasis of blood and maintaining appropriate blood composition. That includes maintaining pH, the volume, the pressure, the electrolyte levels. So we're going to talk about the 8 major functions of the urinary system. First one is regulation of blood ionic composition. So the kidneys will get rid of, yes, any excess ions. But if you're low in certain ions, it will retain them. So I like to think of the kidneys as kind of a gatekeeper. The kidneys can determine what needs to stay in your blood because it's either low or it just doesn't make sense to get rid of it, or get rid of things from your blood because they're either waste and dangerous if they accumulate, or we are getting too high in that molecule. So it regulates your ionic composition, your sodium, potassium, calcium, chloride, phosphate ions, a number of different ions. Second major function is it contributes to the regulation of your blood pH. We've talked a little bit about blood pH in the past in the context of the respiratory system, in that both your respiratory system and your urinary system help maintain blood pH. If you recall, your respiratory system helps to get rid of carbon dioxide, which contributes to the acidity of blood. Well, your kidneys help get rid of hydrogen ions or protons. So your kidneys are almost always actively removing hydrogen ions. And therefore, urine is typically acidic because we're just moving these protons, which is the definition of an acid, from the blood into urine. It also is very important in retaining the bicarbonate ions. So we don't want to lose these bicarbonate ions because they act as a buffer in the bloodstream. So notice these two molecules, the hydrogen ions and the bicarbonate ions, typically are moved in opposite directions. The hydrogen ions leave the blood and therefore go into urine. Bicarbonate is retained in the blood. We keep it. And that helps maintain our blood pH. Number 3, volume. That's fairly straightforward. You have to make adjustments based on your hydration status. If you're dehydrated, we need to retain water. If you are fully hydrated, we can eliminate water. And blood volume has a direct relationship to blood pressure, which we've done in the past. So blood volume, blood pressure, largely maintained or regulated by moving water, either moving it out of the body or keeping it in the body. Number 5, maintenance of blood osmolarity. Osmolarity is the measure of solutes in a solution. And the solution we're talking about is blood. So it maintains the blood osmolarity, which helps maintain the osmolarity of all tissues. When you are dehydrated, osmolarity goes up. The amount of solutes in a given volume goes up. If your osmolarity goes down, that means you don't have enough solutes. So one way to adjust that is maybe get rid of a little water. So osmolarity is just a measure of solutes in a solution. Number 6, the kidneys make 2 hormones. Now they're the target of a number of hormones, which we will revisit, like antidiuretic hormone, like aldosterone, like parathyroid hormone, and angiotensin 2. So those hormones target the kidneys. They tell the kidney to do something. Calcitriol and erythropoietin are produced by the kidney. Calcitriol is active vitamin D, which helps bring in more calcium from your diet. And erythropoietin, or EPO, stimulates red blood cell production by bone marrow. So the kidney can produce a couple hormones. The kidney can also produce a little glucose. So it can actually contribute to blood sugar regulation. It's not a major player in maintaining blood sugar, but it can contribute to the increase in blood sugar by taking certain amino acids and converting them into glucose. And then finally, number 8 is getting rid of waste, which we probably already knew. Urine has a lot of our metabolic wastes in it, like urea. We can also get rid of toxins and certain drugs by excreting them into urine. So those are the 8 important functions, and these are all happening at the kidney. The kidney is the organ doing all this. The rest of the system, the ureters, your bladder, and urethra, are there to get rid of urine. Looking at the gross anatomy of the urinary system isn't too bad. We need to be able to identify kidneys and note their function, which is all 8 functions on the previous slide, but as a result of those 8 functions, the kidneys produce urine. You'll notice that one of the kidneys is a little higher than the other. The right kidney gets pushed down a little bit during development because of the large right lobe of the liver, which is not shown in this picture. So your right kidney is slightly lower than your left kidney. You'll notice that there's blood flow going into the kidney and then back out of the kidney. So renal artery and renal vein. Ureters are transport tubes that use peristalsis to help move urine down to the urinary bladder. You'll notice the ureter is actually attached to the back of the bladder. Therefore, the bladder can hold that urine for a given amount of time, and then elimination from the bladder is done using the urethra. So those are the 4 major organs of the urinary system. We're going to spend most of our time looking at a kidney and learning about the functional unit of a kidney, which is called a nephron. This is just another picture giving us a good idea of where these kidneys are located. This is a transverse section at about L2, and we're looking up at these organs. So note the view. We're underneath looking up. A couple things to note. One, the kidneys are retroperitoneal. They lie behind the peritoneal cavity. You can see a little of the cavity in here. These are all peritoneal organs in that they are covered and surrounded by the peritoneum. The pancreas is also retroperitoneal, so it's behind. See it behind the stomach. Note the liver on the right side. Note the spleen on the left side. It looks like this left kidney is larger, but again, it's just at a different level. So when we do a cross section, quite often the kidneys don't quite look the same size because you're slicing through them at different levels. And then the other thing to note is the layer of fat that surrounds kidneys. This is known as the adipose capsule. This is a protective layer of fat surrounding each kidney. The kidneys aren't very well protected by bones. A couple of the ribs will protect kidneys, like the last 2 ribs, ribs 11 and 12. But other than that, there's not much hard organ to protect them. So we use a lot of adipose tissue. Looking at a kidney, we see that there's a renal hilum. So that is this indentation. Gives the kidney its kind of classic kidney bean shape. It's got this area houses all the things that deliver into the kidney or out of the kidney. So a renal artery delivers blood in, renal vein delivers blood out, ureter delivers urine out. There would also be lymphatics coming out of this renal hilum. There would also be nerves. There's nerve supply into a kidney. The internal anatomy of a kidney, we want to make sure we understand that there's a cortex, which is the outer layer of a kidney, shown kind of in a lighter color here. Then there's the medulla of the kidney, and the medulla is divided up into pyramids and columns. The pyramids, shown a little darker here, contain a lot of the little tubes of the nephron. So you'll notice this is a single little nephron. Each kidney contains about 1 million nephrons. So a kidney is really just a package of nephrons. And if you can understand how a nephron works, you can understand how a kidney works. Parts of that nephron we're going to note are in the cortex. Parts of the nephron are found in the renal pyramids, found in the renal medulla. As these renal nephrons function, they produce urine. So the last part of a nephron is this little collecting duct and papillary duct, and we'll look at all those regions in a moment. But urine is in essence dripping out of these little nephrons. So it needs to be collected on this inside. This is known as the pelvis. So urine gets collected in the pelvis, and then it gets removed out of the kidney using the ureter. So that's a little bit of the, if you will, the external anatomy and the internal anatomy of a kidney. Blood flow, blood supply is a very important topic. The idea here is you have one renal artery going to a kidney, but there's 1 million nephrons. So how do we get blood to every single little nephron? Well, you have to branch and branch and branch that renal artery. So this is just kind of the blood flow through the kidney and then back out of the kidney. I'm going to highlight the more important blood vessels for us to understand. But you obviously begin with the renal artery. That's going to be the big one renal artery per kidney. It's going to divide into segmentals. So those are just smaller but more numerous. There might be 3 or 4 of those. Those are going to divide into interlobar arteries. Lobar refers to the fact that quite often we think of a kidney as different lobes, and those go in between the lobes. Then they arc, so they're called arcuate. Then they go out into the cortex, where they are called interlobular. Then, very important, they supply a nephron. And the arteries, by now they're arterioles, they've gotten very small, that supply each nephron is known as the afferent arteriole. That guy is pretty important. There's 1 million of them, because each of the 1 million nephrons needs its own blood supply. So if we expand on this nephron, notice that this nephron, when we'll look at the anatomy in a minute, has blood flowing into it by the afferent arteriole. That afferent arteriole then turns into a balled up capillary called the glomerulus or glomerular capillaries. That's where the nephron is filtering out fluid and solutes, which we'll talk about that when we get to nephron function. Whatever doesn't get filtered out leaves that glomerulus inside the efferent arteriole. So afferent goes in, efferent comes out. Then the efferent actually forms a set of capillaries called the peritubular capillaries because they surround the tube part of the nephron. Then it's just a matter of getting the blood back out. So there are veins that merge into eventually the renal vein. So a lot of little blood vessels in a kidney. We're going to focus in on just a handful of these, not this entire list. But kidneys get a lot of blood flow. Kidneys are fairly small. They make up less than 1% of your total body mass. About a 0.5% of you is kidney. But at rest, those little kidneys get about 20 to 25% of your cardiac output. If you recall, cardiac output is about 5 liters. And 20 to 25% of that blood goes to a kidney when you're resting. Kidneys are much more functional when you're at rest. That's a good time to clean and filter blood. And when you're more active, we kind of decrease that blood flow to the kidney so we can increase blood flow to other organs. So renal blood flow is at about 1.2 liters per minute when you're at rest. You'll notice that the asterisks are to emphasize the more important blood vessels on our list.